All right, this is going to be the video solution guide to the formula weight or molar mass worksheet. It's going to incorporate some of our prior knowledge of writing chemical formulas, so hopefully you haven't forgotten that. Otherwise, you're going to find this like a stucco bathtub. It's going to be rough. So here we go. Calcium sulfate. So first thing you have to know, calcium's charge is always 2 plus. Sulfate, polyatomic. Hopefully you remember those. SO4, it's 2 minus. Because it's 2 plus and 2 minus equal and opposite, they cancel. So this is the formula for calcium sulfate. If you put the 2's there, you're going to get the molar mass wrong. So you have to know how to write calcium sulfate. So what we're going to do is we're going to add up their molar masses. So you look at calcium. Calcium weighs 40.08. Let's see, there's one sulfur at 32.06. And it looks like there's 4 oxygens, each weighing 16. So you're going to take 4 times 16 plus 32 plus 40. When you do so, it's going to be 136.14 grams per mole. Okay. Anytime we're dealing with molar masses, we're going to do the 2 decimal places because our balance is weighted 2 decimal places. These numbers don't count for sig figs because those are standard values. They are taken from a table of known values. They're not a measure. There's no estimation. That is the mass of those elements. So that is the molar mass of calcium sulfate. Second one, we have lead 2 iodide. Well, that tells you lead is 2 plus. Iodine is always 1 minus, and so what's going to happen? We're going to cross these. The 2 comes down behind iodine, so there is lead 2 iodide's formula. Lead weighs 207.2 grams, and there are 2 iodines, each at 126.90 grams. Multiply 2 times 126 plus 207.2. You're going to get 461 grams per mole is going to be the unit for molar mass. Okay, mercury 1 carbonate. That tells me mercury's charge is 1 plus. Carbonate polyatomic is CO3 and it's 2 minus. When you cross them, 2 comes behind the mercury. So there is mercury 1 carbonate. There are 2 mercuries, each at 200.59. Let's see, there's 1 carbon at 12.01. And there are 3 oxygens, each at 16. And so when I add those up and sum them, 461.19 grams per mole. Okay, nitrogen dioxide. So this is molecular, both nonmetals, so we don't cross them. It's just 1 nitrogen, 2 oxygens, NO2. Nitrogen is 14.01. There are 2 oxygens, each weighing 16. And so multiply and then sum. When you do so, 46.01 grams per mole. Aluminum oxide. Let's see, aluminum is 3 plus, oxygen is 2 minus. So they cross, Al2O3 is your formula. Let's see, there's 2 aluminums, each weighing 26.98. Looks like 3 oxygens, each weighing 16. Multiply, and sum, 101.96 grams per mole. See, ammonium acetate, we have 2 polyatomics. Ammonium is polyatomic, it's NH4 with a 1 plus. Acetate is C2H3O2, and it's 1 minus. 1 plus and 1 minus equal and opposite, they cancel. None of the subscripts move, they're part of the formula. There's ammonium acetate. So let's see, I have 1 nitrogen at 14.01. Hydrogens, you can do them separate or you can add them because we have 4 here and 3 here. I'm just going to do them all in one place. It doesn't matter. Either way, you get the same answer. So I'm going to say there's 7 of them total at 1.01 each. Let's see. There are 2 carbons, each at 12.01. And 2 oxygens at 16. Make certain you don't count the hydrogens again if you already did that. Multiply, and then sum everything together. Should be 77.10 grams per mole. Okay, dinitrogen pentoxide. That tells me 2 nitrogens, penta is 5, N2O5. 2 nitrogens each at 14.01. There are 5 oxygens each at 16. Multiply, and then sum. 108.02 grams per mole. Next one is zinc nitrate. Zinc is always 2+. Nitrate is NO3 and it's 1-, Zn. And whenever you bring a polyatomic, or excuse me, a charge behind a polyatomic, you must always use parentheses. Okay? So let's see, we have one zinc that weighs 65.38. There are, let's see, 2 nitrogens at 14.01 each, because the 2 applies here. It also applies here, and it multiplies. So that means there are 6 oxygens each at 16. Multiply, and then sum. That should be 189.40 grams per mole. Okay, iron 3 hydroxide. That tells me iron is 3+. Hydroxide is 1-. So once again, you're taking a charge and putting it behind a polyatomic. You got to slap that thing inside parentheses. That tells us there's 1 iron at 55.85. Looks like 3 oxygens each at 16. 3 hydrogens each at 1.01. Multiply, sum. 106.88 grams per mole. Okay, last one, sodium bromide. Sodium is 1+. Bromine is 1-. Equal and opposite, they cancel. NaBr. Let's see, there's only one sodium, weighs 22.99. There's only one bromine, which is 79.90. When I sum these together, 102.89 grams per mole. And that's it.